Good morning, good afternoon, good evening. Thank you very much for tuning in to today's lightning interview. Today, I'll be speaking with Greg Michaelson, co-founder of Zerve, about the Modern Data Science Development Toolkit. My name is Alex Landa. I'm the head of content here at ODSC, and I will be your host for the rest of the day. So, first of all, before we get right into the interview, I do have a few things to bring up. First, we do have a number of upcoming events here at ODSC. We have a lot of webinars. In the near future, we have another meetup co-hosted with Basis Tech next week. That'll be in Somerville. We have ODSC East and the Data Engineering Summit coming up in Boston in April 23rd through 25th. We have a lot of speakers announced, and it's shaping up to be a really good event this year. So right now, of course, you can scan this QR code, see a lot of what we have going on with ODSC East. And co-located for the first time, and the first time in person, will be the Data Engineering Summit. And here we're going to be talking a lot about everything data engineering. So from ETL to working with data scientists on their algorithms and so on. So it's shaping up to be also a very good event. And lastly, this interview will be part of our new AIX podcast. Right now, I think we're at 7 episodes. They're all live. We're on a number of platforms, and you can go check them out whenever you want. And with that, I would like to formally bring on Greg.
Ahoy.
Hey, Greg, how you doing today?
Can't complain. How about you?
Doing all right. So, first thing is, why don't you tell us a little bit more about yourself and your role at Zerve, and of course, what Zerve does.
Yeah, so I've been in the data science space probably, 10, 20 years. Wow. Now that I say that, it makes me feel old. I was at DataRobot since 2015. So DataRobot invented automated machine learning and did some really interesting stuff in that space. I was the chief customer officer there for a little bit. And I got a LinkedIn message one day after I left DataRobot in October of 21, I suppose. And shortly after, I got a LinkedIn message from this guy named Philly in Ireland who had a bone to pick with DataRobot. And he and Jason had developed this idea that 100% of AI projects require code. And he was asking questions about low code, no code environments and how they fit in with this idea that you actually need code to really build and deploy serious things. And he was collecting feedback, but it turned out that a lot of what he was saying really resonated with me. And so I became an advisor to the company that was very new. They were only a few months old at the time. And then eventually flew over to Dublin, had a few pints of Guinness. And, before long, I was co-founder at Zerve with Philly and Jason. And we were building, I think, the most sophisticated data science development environment that's ever been conceived of. So there's some really cool stuff going on there. I joined as chief product officer, and me, Philly, and Jason, the 3 co-founders, we've got some good stuff cooking. So we started building probably about 15 months ago in terms of actually building the product that we released on Tuesday. And we're super excited about what it is and the reception that we've got and where we're going and all that sort of stuff. So let's see.
Well, you heard it here that Zerve is brand new, just came out on Tuesday. So good time to check out something new and say that you used Zerve before it became cool. Right. But on that note, we're here to talk about the toolkit. So first of all, what are some of the key obstacles or challenges that a lot of people face in the modern data science toolkit?
Well, the 2010s were all about low code, no code stuff. So DataRobot was big in that space. H2O was, Dataiku was all low code, no code. Anybody can be a data scientist. Anybody can build models. Anybody can, the citizen data science, rise of the citizen data sciences is the story of the 2010s. Arguably, I think everyone pretty much agrees that has not lived up to the promise. I interacted with all of our customers at DataRobot, and I've never actually seen a citizen data scientist, except in like grainy photos in national forests. But so the challenge is that anybody that's serious about getting value out of their data is writing code, and the coding environments that exist for doing data science were written for different people. So there are really two options when it comes to writing code in the data science space. One is notebooks. So Jupyter notebooks have probably 95% of the market. Although there are lots of kind of cloud notebooks that have forked Jupyter and added some bells and whistles and stuff, things like Hex and DeepNode and some of these others. Google Colab is another example. But they're all forked to Jupyter. Those tools are great. They're the only code-based tool that was really designed for data exploration and interactive data analysis. But unfortunately, they were written by academics to be used as classroom scratch pads. So they're super brittle. And so anything that you build in a notebook is going to be unproductionizable, basically. And so what ends up happening is that data scientists will start their work in a notebook type environment, like Jupyter, say. And at some point they go, oh, wow, this is big. We got to do something serious here. We're actually going to want to use this in some serious sort of situation. And so they'll have to copy paste their code into the other option, which is like an IDE, like a VS Code or a Spider or a PyCharm or something like that. Now, those types of environments, the IDEs are great. They're super stable, written for written for software engineers to build apps. The problem with them is that they suck for data exploration. So trying to explore data and understand what's happening with your data in an environment like VS Code, say, is a nightmare. And so we call it the data science Stockholm syndrome, because data scientists sort of like are very, very animated about their development environments, but all the environments that are out there that are available to be used are actually really poor for doing the work that they've been set out to do. And so those are the only two options, really, IDEs and notebooks. And so what we've tried to do at Zerve is to build an environment that gives you the best of both worlds, an interactive, exploratory environment that gives you the stability that you need in order to do something serious that you could actually use in some kind of a production environment.
Well, that does sound pretty helpful. So I'm sure we're going to see a lot of signups right after this. I'm hoping. But you've mentioned no code, low code, and things like that a couple of times. So next question is, will programming languages continue to be important in the modern data science development toolkit, or do you see them being increasingly replaced by no code, low code, and AI code assist tools?
The problem with there's two options there, really, right? There's these low code, no code environments like your data robots and other tools like that. Those tools are pretty much, in my view, dead on arrival. Just to give you an example, when I was at DataRobot, we and the pandemic broke out, we put about 100 engineers on the problem of forecasting the spread of the pandemic, because frankly, the CDC forecasts were just awful, and nobody seemed to know where the pandemic was going. And so we put together a fairly sophisticated team to try and predict at a county level on a daily basis where the pandemic was headed. And that's a testament to the vision of our at the time CEO, the founder of DataRobot, Jeremy, to really take the power of AI and really use it to try and help at a very critical time where tons of people were dying on a regular basis from the pandemic. And so we put 150 engineers on this problem of forecasting the spread of COVID on a super, super granular level, both time-based and geography-based. The ironic thing about it is that even though we were at DataRobot, this automated machine learning company, we couldn't actually use DataRobot for any of that work. We literally coded that entire COVID forecasting machine from scratch. because that's the fatal flaw of these low code, no code tools, is that they're great for happy path problems. So if there's nothing unusual about your problem, and there's no twists and turns, and everything is as it's expected to be, then you can build a customer churn model in low code, no code tool all day long. But the moment you have something that has a little complexity to it, or some twists and turns, or something that's sort of non-obvious, then suddenly you hit a roadblock with these no code, low code tools, and you have to move to a coding environment, start from scratch, basically. So that's one option, the kind of mouse-driven data science tools. We think they're dead in the water at Zerve. The other option is generative AI, right? So these LLMs are really good at writing code, but they're not to the point yet where they can reliably write code that does exactly what you want. And it turns out that the devil's in the details when it comes to building data science type solutions, and it has to be right. So I think what we'll see in that space is kind of a hybrid type model where the sophisticated folks that know, the experts, the data scientists that know how to do this work will use these LLMs as ways to expedite, to speed up their work. But we're not at the place where you've got machines that are writing these solutions from scratch and can do so in an unsupervised way. So I don't think we're there yet. But these LLMs keep getting better and better. Who knows? I mean, it's a brave new world out there.
Well, I mean, these tools have been around for pretty much a year and a half at this point, some of these, and they've already grown a lot. So might not be impossible to see them getting more done in the near future. I wouldn't be surprised, but
I use GPT all the time for plotting. So when I want to visualize some data, it's super great for saying, hey, look, I want this plot, I want these colors, I want this structure, and it kind of gives you what you need for a start. The LLMs are really great for a starting point, and then you can take that and sort of tweak it and customize it to be exactly what you need. But it definitely needs checking at this point. The hallucination problem is a significant problem.
Well, hopefully we get somewhere with that. I mean, I know it's still pretty early. It's fascinating what LLMs can already do, but let's get through one problem at a time there, I guess.
Here.
But you've mentioned AutoML a couple times as well. So has automated machine learning changed the way that data scientists approach model building and deployment?
Well, the problem with, here's the thing. The data robot arguably invented automated machine learning. They were the first ones to really take it seriously. And excuse me, back in the day, the way data robot sort of got successful and famous is to win some Kaggle competitions using these automated machine learning type solutions. And that's legit. But what you get out of these automated machine learning tools is trained models. And so, if I feed a data set into an automated machine learning model, then what you get is a model that you can either take or leave. So if I train a churn model, and maybe an automated machine learning solution trains 30 or 40 alternatives, maybe a random forest and a logistic regression and a support vector machine, a neural network, and who knows what, I pick the one that works the best, and then I deploy that one. As long as those models are good and are acceptable to the users, then you can take one and use it. But there's really no tweaking at that point. And so the AutoML gives you kind of a take it or leave it type approach, where you kind of get what you get when it comes to these type of solutions. And that's not always ideal because, like I said, the main problem with these low code, no code tools is a lack of flexibility. That when your problem is sort of non-standard, then suddenly you're faced with a situation where none of these tools will do what you need them to do, and you can't tweak or edit them enough to actually get them where they need to go. So one of the things we did at Zerve is we created an open source platform called Pipelines, an open source package, which is an AutoML, but it's built for experts. So instead of giving you trained models, what it gives you is training code, so that you can actually feed a data set, and it will detect your variable types and propose some pre-processing steps and some models to train and things like that. But then instead of actually doing the work training them, it just gives you the code to do the training, so that if you want to change something, like say how you handle missing values, you want to do mean imputation instead of median imputation, or whatever it might be, you can actually go in and edit that code and change it to what you want it to be. So that's how at Zerve, that's kind of how we think about AutoML. Like, there's definitely a place for reducing the burden of kind of like building these pipelines from scratch. But it's not the type of thing where you want to be delivering trained models. You want to be giving experts who write code a starting point, so that they can take those models and then make them what they need them to be for their particular situation. So I think AutoML has a role to play, but at the end of the day, training the actual models is a fairly small part of the solution, and you need it to be flexible enough to be viable for any problem, no matter how complex it is. So I think those are the main things you want to look for when you're looking at an AutoML type solution.
Great. Thank you for that. So we've touched on a couple of different pieces of the workflow, and a lot has obviously been changing. I mean, data science changes every day, week, month, year. But in terms of some bigger picture things, how is the data science workflow evolving, would you say? And what tools and techniques are streamlining each stage, and how are they especially impacting team collaboration?
That's actually a really interesting question. The whole collaboration question is really interesting. So if you think about when we were working on the COVID forecasting machine, one of the things that we encountered fairly regularly was this problem of collaboration. Because what we had was teams all around the world. So we had a Europe team, we had an India team, we had a team in Japan, Singapore, we had several teams across the US. And what we wanted to do was to be able to sort of follow the sun and kind of hand off projects all around the world, so that 24 hours a day, somebody could be working on advancing the ball. Because at that time it was panic mode, right? I mean, we were trying to go as fast as we could, because we were working with vaccine manufacturers, we were working with the U.S. government, with all the different parties that were trying to make the pandemic, moderate the pandemic. And so we wanted that follow the sun model. And as we were writing code, we were actually in Jupyter notebooks and really struggling with the whole collaboration thing, because there's no good solution for coding collaboration today. There's really two ways that people do it. One is asynchronously with GitHub, right? So you've got a bunch of folks coding, and they're sort of like working on their own branches. And as they finish different parts of the code, then they'll create pull requests, and they'll push that code up to GitHub, and somebody will review it, and they're looking for handling merge conflicts and all that kind of stuff to try and get it merged into some master branch that then everybody else can pull down. And it's an asynchronous kind of collaboration, which works, but it's not, I don't think, ideal for a fast-paced type solution. So the other one, all the innovation that's happening in the notebook space today is around collaboration. And so, like, if you look at like a Google Colab, say, that is a server-based deployment of Jupyter, say, like Jupyter is, some server-based deployment where you can have multiple people log into the same Jupyter notebook and try to work together and interact in real time, so synchronously. Which the problem with all those solutions, and there's lots of them out there. There's a company called Hex, and they've raised like $100 million. There's a company called Deep Note. I think they've raised like 25 million, something like that. The problem is they all stink. The collaboration with these tools is awful. They have to do things like locking cells when somebody's editing them, and there's like a significant lag between when somebody will will type and run code and what everybody else gets updated on. It's definitely not your Google Docs type experience where you can have a half dozen people in the same document all kind of like editing it simultaneously. And so there are really no good kind of synchronous collaboration tools out there. If anybody has used Google Colab, you know it's awful. Like it's a horrible experience trying to get multiple people in the same environment writing code and running code and so on at the same time. Part of that is a weakness with Jupyter. So all of these tools are forks of Jupyter because Jupyter is open source. And Jupyter is very sensitive to run order. So like if you run the cells in the wrong order, if you run one particular cell too many times, then you can get into a bad state. And that's why all notebooks today have a restart kernel button. So once you get into a bad state, you click that restart kernel button. It's basically turning it off and turning it back on again. And then you have to run everything from scratch, which is an awful situation. But if you put it onto a server and then you can have 10 people log into the same notebook and they can all run code, then you find yourself on a Zoom call going, okay, nobody run anything. Like, we're about to run it for realsies now, and you restart your kernel and then one person runs it. And so there's a lot of like weird kind of orchestration type things you have to do in order to get those things to work because of that architectural flaw in Jupyter, which gives it the potential to produce inconsistent results if you don't run it in precisely the right order and precisely the right way. So collaboration in the data science coding space, I think shows a huge amount of potential, but there aren't any tools today that actually make it useful. If you think about the design space, so if anybody's familiar with Figma, Figma is a design tool where you can do like wireframes and design type work. So if you wanted to prototype an app, say, you could lay out all the buttons and the widgets and the things that you might need in that app. But the thing about Figma is that you can do it all simultaneously. So you could have 10 people in Figma all laying out things on different pages on the same page, all working off the same components and so on. And that's why Figma is massively valuable and huge. Everybody uses Figma at this point. Before Figma, what you would have is you'd have everybody in, say, like Adobe Illustrator or something like that, doing these layouts, and they would meet on a Friday and they would go over what they've done and they'd collect feedback, and then they'd go away for a week and work independently, and then they'd meet the next Friday and so on. And that was just the way everybody sort of thought that it should be done. But then Figma came along and suddenly everybody could work in the same document all at the same time, and it changed literally everything. Well, that's what's happening in the data science space at the moment. So one of the things we've seen at Zerve is that now that we've introduced this development environment that allows true real-time synchronous collaboration, you suddenly have this capability to all be in the same document, running code and be in a stable environment. And it's, I think, going to change the way that people write code and the way that teams work together in terms of like building data science. Because really, if you think about the way that data science projects get developed, there's a big diversity of teams involved. So they might start with like a data engineering team that's writing SQL in some sort of a database environment where they're querying some database and they're landing that data somewhere, and then that data gets handed off to various data science teams. And some of those data science teams might be statisticians that are using R, and some might be machine learning engineers that are writing in Python, and they're all working in different environments. And so at some point, all of that has to come together in some sort of a production environment. So there's a huge strain on like DevOps resources and people that can actually pull all those different threads together into the same environment. And it's just super problematic in terms of the way that these things work. So we see that there's going to be kind of a revolution in terms of how data scientists and data engineers, and we call them code first data users, will be interacting and working together over the course of the next few years, now that these collaboration type tools are becoming possible.
Great. Yeah, I mean, a lot of that makes sense, especially as a lot of these teams are working remotely together. It's not as simple as just, transferring someone to the person next to you. It's, there's definitely a market for something that works well collaboratively. But as we're talking about these different tools, a few big things have come out in the past year. So not long ago, OpenAI came out with GPT models, and then later in the year there was a Llama 2 model. So how can data scientists leverage the power of open source tools while still benefiting from the features and support offered by commercial platforms, and how can you strike a balance between the two?
Yeah, one of the things that I've seen sort of over and over again is that organizations think about open source and say, "Oh, that's free. We're going to use that," as opposed to some sort of a vendor type solution. It is definitely a kind of a misnomer to think that the cost of ownership of an open source solution is zero compared to a vendor solution, which obviously has some cost to it. There is a tremendous cost associated with building and maintaining an open source solution. A lot of that is, having to deal with like updates and maintaining the solution as patches and changes to the open source software come out. And some of it is like the learning curve around doing it properly. And, at DataRobot, we spent tons of time helping people set up their Kubernetes clusters and getting their servers working properly and all that sort of thing. It's not obvious that every organization out there should also be in the business of, like utilizing open source and maintaining all their own servers and stuff like that. Some should, certainly, and organizations have to make their own decisions about, what parts of their stack are going to be open source and are they going to be responsible for kind of building and maintaining, and what parts are going to be vendor-based solutions and will they buy, right? No organization, for example, is using like open office, right? Everybody is using Microsoft Office or Google Docs because they're just better. They have a cost associated with them, no question about that. But the cost of trying to maintain open office, say, compared to the cost of buying Google Docs, it's no comparison. The lost efficiency, the difference in features, the capabilities, and so on. There's no comparison between the two. Google Docs is clearly better. So it's not a question of, should I use the free stuff or should I buy something? Because the free stuff's not actually free. And the level of sophistication required to like maintain those things, particularly as the complexity goes up, is definitely non-trivial. So I guess it depends. To me, it depends on the particular situation and how stable the open source type solutions are. When it comes to development environments, using Jupyter is an open source solution, for example, but it has significant drawbacks, and there are drawbacks that are fairly difficult to overcome. So like Jupyter Notebooks, for example, were originally built to be classroom scratchpads for the academic setting. And that's what they're always going to be. That's sort of like hard-coded into the genetics of Jupyter. And so, it's great to use them. They're fantastic for data exploration and interactivity. But using them also means that you're going to end up with this burden of switching environments. So everything that starts in Jupyter has absolutely 100% has to end up somewhere else in order to actually be useful, because you cannot deploy Jupyter Notebooks. You cannot safely deploy Jupyter Notebooks. You cannot like wisely deploy Jupyter Notebooks, if you know what I mean. There's lots of stories about running Jupyter headless and stuff like that. And it's madness. It's just absolute insanity because it's never designed to be a tool that's used for production. And so trying to force it into that mold just increases the cost of ownership and makes life miserable for everybody involved. So to me, it's a balance between how do I balance the cost of maintaining an open source solution, both in terms of like the expertise and the people required to do that, because it's definitely not insignificant, and the convenience and cost of these more, the paid solutions. It's just a balance.
Right. Well, there's always a good middle ground for using each type, and depending on what the company is capable of, their needs. but there's good options for both out there, of course. So as we're talking about these different models and challenges, what are the challenges and best practices in deploying and monitoring machine learning models in production environments?
Oof, that is a complicated question. Mainly because the definition of deployment is not obvious. There are certainly some types of solutions where deployment is basically taking an analysis and copy pasting it into a PowerPoint and then having a meeting. That's deployment for an awful lot of solutions that get built out there. There's this whole kind of like industry of ML ops that's been developed, and I would argue that ML ops was developed a bit prematurely because the vendor space was definitely ahead of where the industry was. We had an ML ops product at Data Robot, and the main problem there is that nobody was actually deploying any models. so it was interesting having those conversations about ML ops and how to charge for it and how to work with companies that were doing deployments and so on, because most people were at the stage where they were experimenting with machine learning, and they weren't at the stage where they had models that were in heavy use and were ready to kind of be deployed in a serious way. So when you go out and you survey companies that have done this kind of work, I see you're frozen. Are you still there? Can you guys hear me okay?
I can hear you fine. I think my internet just...
That's okay.
Yeah.
No problem. I thought it might be my internet. I didn't want to be just like droning on if we were having a problem, but yeah. What we've seen is that as we've talked to organizations, there's a pretty significant diversity in terms of how they deploy these models. There are an awful lot of companies that had models to deploy that were of significant value to the business and invested significantly in deployment pipelines. And so they run their own Kubernetes clusters. They're using tools like Airflow and MLflow and all these different tools to actually do these deployments. And they've built the infrastructure that they need to do that and to do it reliably. That's definitely a minority of organizations. Most of the time when you talk to companies about their ML stack, they will kind of look at their feet and kind of like shuffle around and say, well, we're still trying to figure it out. And we don't really know where we're going to end up here. They see the value. They're still sort of experimenting, but they don't have a huge number of models, quote unquote, in production. And so they're trying to kind of figure things out. So I think the ML ops space is definitely ahead of the market in terms of how to do this. And I'm not sure that they're building the right stuff. I think time will tell where we end up here and who's thinking about it right. But for the most part, most organizations really aren't in that space yet. It depends on the industry, of course. Like your financial institutions are a bit ahead of the game, credit scoring and stuff like that. Those are all sophisticated models. Insurance pricing models are fairly sophisticated. Your telecom companies are doing things like predictive maintenance and stuff like that in a relatively sophisticated way. But your biggest retailers are probably doing some stuff like demand forecasting and things like that in the retail space. But everybody else is kind of like still trying to figure things out. Oil and gas hasn't really done much in the space, apart from a few exceptions. You've got your real retailers that aren't as sophisticated as like your Walmarts and your Krogers and stuff like that are still trying to figure things out. Your healthcare companies are still thinking and trying to make some headway, except for your biggest players in that space. So I think the jury's still out on a lot of the ML ops stuff, but the next 5 to 10 years are going to be really interesting in that space.
Yeah, agreed. So you've definitely jumped into generative AI. I mentioned that a couple of times. So one of my last questions is, where is generative AI being used creatively in data science and part of the toolkit right now? And where do you see it going in the near future?
So I can tell you how we're using it at Zerve. There's some tremendous opportunities in the coding space. We think that there's lots of really interesting stuff around taking. So one of the things, for example, that you can do in Zerve is you can take a Jupyter notebook and you can drag it into the app, and we'll parse it for you and convert it into a structure that is completely stable, so that you don't have to worry about this problem of inconsistent results if you don't run it properly, of inconsistent results if you have multiple people collaborating on the same notebook. And so we're using generative AI and LLMs to do like refactoring. So have a look at this notebook and tell me how to optimize it. That kind of stuff. Certainly in the development process, there's lots of opportunities to see, where you have opportunities to speed up that process in terms of efficiency and writing code, all that sort of stuff. There's some really cool stuff, like Copilot is super awesome. There's lots of opportunities there in terms of like speeding things up around the development of these types of things. And that's mainly where we're focused at Zerve, is trying to use LLMs to make the coders, the experts, more efficient at the work that they're doing. I don't think that we're at the place where we can start replacing coders. The LLMs certainly are not good enough yet to take a prompt and turn it into a finished product. But there's definitely a place for these LLMs to speed up that process by providing kind of like boilerplate that is then used by experts to develop something real. So I think that's where we are now. But things are developing so fast, who knows? I mean, who knows how good these things will become? My guess is that they'll become very good very fast, but time will tell.
Well, you just mentioned LLMs as part of this. So where have LLMs and retrieval augmented generation where have they been integrated in the data science workflow, and what unique advantages do they offer?
Yeah, it's mainly, to me, it's around developing these solutions. So it's mainly around like if I can start with something developed by an LLM, like if my prompt was something like, hey, I'm trying to train a random forest on this data set. Here are my column names, and this is what I'm trying to accomplish. Give me some code to do that. Well, that's going to save me a few hours of work. I'll probably have to go in and change some things and tweak it and build some changes into the code that actually gets developed. But using LLMs as a way to get to a starting point is a tremendous time saver. It's huge efficiency gains around that type of work. So and then the other component is explainability. So I think auto documentation of code is really interesting here. Things like, okay, I've got this block of code. Like if I was a DevOps engineer and I was handed a Jupyter notebook to try and productionize, the first thing I would do is feed it to an LLM and say, okay, explain me what's going on here. And get the LLM to produce for me an explanation of what the code was actually doing, as a way to kind of understand what somebody else is doing. So I think there's some like really interesting explainability type solutions in the LLM space, particularly when you're doing handoffs, like collaboration between different coders, because reading somebody else's code is a nightmare. And so letting the machines do it and kind of try and explain what's going on, I think is a potentially really, really useful application of this technology.
Yeah, that'll be cool to see. So one last question before I have some questions about Zerve. So we've been talking about a lot of these new trends and technologies. So what are some emerging trends and technologies that are coming out or in the early stages that you think will redefine the data science toolkit? And even if they aren't out yet, how can someone prepare for the inevitable change of new additions to toolkits?
So we think that collaborative coding is a really interesting area. There's no real one of the biggest innovations in terms of work that I've seen in the last 5 years, say, is what Google did with Microsoft Office. So coming out with Google Docs, where you can have lots of people in the same document writing code, not writing code, but writing words, like editing a document all at the same time, is remarkable. It's so remarkable that I would never, ever consider using Microsoft Word again. So Google has clearly won that battle, and it's no contest. So that sort of that sort of collaboration has not hit the coding world yet. Like, there are no good tools for doing that kind of work, and so I think that's kind of a frontier. Because what you've seen up to now is like you want to do like paired programming. Well, you have to get on a video call and look over somebody's shoulder and like figure out, anybody who's done it knows that it's a little cumbersome. But if you had an environment where you could conceivably collaborate in a project across an entire code base, say, for developing data science or even an application or whatever it might be, I don't think anybody knows what that would look like yet. So I think there's some tremendously interesting collaborative coding examples that I'm excited to see how they sort of develop. I also think there's a lot of really interesting stuff going on with things like Google Copilot or with GitHub's Copilot and some of the other stuff that's going on in the LLM space. Like things like automated refactoring, code explanations, lots of really cool stuff happen. We've already sort of talked about a lot of those kinds of things, but that's a really, really interesting space. And then the whole question of, are we actually going to be writing code for much longer with the way LLMs are developing and all that sort of thing? Who knows? Who knows how much longer we'll be writing code with the way these models are developing? We shall see, I suppose. I think there's going to be a significant amount of time between now and when we become irrelevant in the coding space. But the technology is advancing really fast.
Oh, that's true, but we can only look so far ahead at a time. I mean, I didn't expect all this stuff with LLMs and generative AI to pop up. When I first started here 5 years ago, it was just machine learning and deep learning and NLP. And then overnight, it's, hey, here's generative AI going to change everything.
Yeah, nobody expected it. It's crazy.
Well, great. You've given us a lot of information about the toolkit, but now I want to learn a little bit more about Zerve. So what makes Zerve different from other data science development environments?
So Zerve is what would happen if Jupyter and VS Code and Figma all had a baby. So what we've tried to do is give our users all of the capabilities of Jupyter, all the kind of interactive inline results, because Jupyter is great for data exploration, but it's just not stable enough for anything serious. So we've tried to take the good things about Jupyter, which is interactivity and exploration capabilities, and combine it with the good things about VS Code and all the IDEs, which is stability, the ability to write code that will produce the same exact output regardless of what happens. And then combine that with Figma, which gives you all the collaboration capabilities to write code as a team. We've tried to put all those things together into a development environment that was written by data scientists for data scientists to actually build AI type solutions. So we're building for your data engineers, for your machine learning engineers, for your statisticians, anybody that interacts with data using code. That's the solution that we're trying to build.
Great. Well, that answered my next question of who are the target users. So how has the launch gone so far? I know you mentioned that you've been building it for a little more than a year and then it just launched. So how's that been going so far?
Yeah, we launched on Tuesday. It's been a crazy week. I think I've had probably like 3 hours sleep in the last few days. So I'm a little fried, but it's been wild. We were on Product Hunt. I think we finished 11th on Product Hunt, which is a pretty good result, I think. We've had lots of people sign up, gotten tons of feedback. And so it's been really great. So we've had I would say a tremendous response to the launch, and we're fielding questions in Discord all the time, and we're interacting with our folks and getting tons of really, really good feedback. So I'd say it's gone great, and we're super optimistic about where we're headed.
Great. So what are some of the next steps for Zerve? So I'm sure there's going to be some updates and all that. What can early adopters look forward to?
So we've released some really interesting stuff. We've got we've just released a GitHub integration. So that you can track your version history, and you can start to do some of those CI/CD type things within your data science projects. See, the thing that really sets Zerve apart from other data science development environments is that while it gives you that collaborative, interactive, exploratory experience, it does it in an environment that's completely stable. So there's no restart kernel button in Zerve. We didn't use a single line of Jupyter code. And so we don't have that architectural flaw that notebooks have that makes them unsuitable for production. So we give you a stable development environment that then gives you the ability to actually deploy your solution in a from the same environment where you actually wrote it. So there's no copy pasting. There's no trying to fight with your environment to actually get you something that you can use in some real way. So we're moving further and further down that road. GitHub was the latest integration that we've built. But yeah, lots of really cool things coming down the road.
Great. Well, thank you for that. And for anybody interested, you can see the URL here. It is zerve.ai. But looks like we are out of time, actually, or just about. Do you have any final comments about the data science stack or Zerve that you'd want people to know?
Yeah, Zerve, I would just say that we're free. Zerve.ai has a community edition that is free. It will always be free. And if anybody wants to get in there and try out the next big thing, it's just Zerve.ai. You can go in and create an account and get using it. There's no cost to it at all to the user. And we're looking for feedback at this point. So if folks get in there and have some ideas, we'll invite you to our Discord, and you can jump in and give us all the feedback that you can. So at this point, we're trying to build something we're trying to build the data science development environment that we would want as data scientists. And so we're trying to get there with the help of the community. And so we're inviting everybody to get on there and use it.
Sounds good. So hopefully we get some more people to check it out following today's interview. And yeah, that's it on my end. So want to say thank you again to everyone for tuning in. And thank you very much, Greg, for taking the time to talk to us about the Data Science Toolkit and Zerve.
My pleasure. Thanks for having me on.
All right. Thank you. Have a good rest of your day.
Same to you.